Okay, welcome to the fourth and final lecture for this unit. This will be on the importance of graphing and what type of graph you guys should be using when it comes to graphing your plant data or graphing any other kind of data we're going to be collecting from an experiment throughout the year. So we do plenty of experiments. Making graphs is essential, and we're going to learn, the importance of doing that, what kinds of graphs there are. So let's first take a look at why you would want to make a graph. When you're doing a science experiment and you're reporting your results, typically it's kind of hard to actually just gather what has happened during the lab from reading all the results in like a paragraph form. So making a graph here helps summarize data, make the experiment easier to understand, and it can provide a lot of information very quickly. So if you're trying to show in a quick picture how the plant growth of your radishes has changed over 9 months, using a graph could easily show that very quickly on one page. Whereas if you were to write that out in paragraph form, it could take a long time to explain everything that has happened. So using graphs are very easy and a great idea in summarizing data and providing quick information to people. Okay? Kinds of graphs are there then, you may ask? Well, the first graph we're going to learn about today is the line graph. Line graphs have a very stereotypical line, and they all have points in the line. Okay, so either a line graph could connect points, or a line graph can be maybe where points are placed all over the scatter plot here, and then a standard line is drawn as like an average line. Okay. But line graphs all have scatter plots associated with them. The most important thing you got to remember about line graphs is that you only use line graphs when time is involved, okay? Because line graphs show progression through time. So unless you're using time, you shouldn't really be using a line graph because it's really only appropriate there. The only other thing I'll say about this is that time is always going to be on the x-axis. So if we were going to do axes here, your x-axis would be right here, your y-axis would be up there. So it looks like kind of here we're gauging a collection of things over months of the year, and because months of the year shows time and a progression through time, we would use a line graph. So that's your first graph. Second graph is going to be a bar graph. Very typical. Everybody likes to use bar graphs, but you got to be careful. If you're dealing with time, you're going to use a line graph. If you're dealing with categories, then you'll use a bar graph here. So again, bar graphs are used for comparing categories. And again, as you're comparing this, the categories, since those are your independent variables, are going to belong on the x-axis. So x-axis is down here. It looks like we're gauging quantity of something, so the number of something in different countries. And so our categories, which are countries, are listed below, and our count, which is what we measure, is listed on the left-hand side. So this bar graph is appropriate because we've got categories, and that's why we're using it. So again, with bar graphs, categories. Next one here is going to be the pie chart. Pie chart can be sometimes misused, but in this case, and in some other cases, it can be used appropriately. So a pie chart is used when you're trying to compare a piece of a whole or an entire population. So let's say you were going to see how many current students in our school came from different countries, or maybe their grandparents came from a different country. So you may find that a majority of students have their parents and grandparents come to the United States. Maybe a smaller percentage come from the United Kingdom, smaller from Canada, some from Australia, and maybe some from other countries, all lumped into one category. The reason we're using a pie chart here is because we're comparing the whole school. okay? If we were just counting individuals and sampling in random classes, we wouldn't necessarily use a pie chart. But since we're counting everyone in the whole school, we can use a pie chart. So when we're comparing pieces of a whole, we're using a pie chart. So those are our basic three kinds of graphs. We're really not going to venture outside of those three, but be aware of those and use them appropriately as we do more experiments. All right, last thing we'll go through is how to make a graph. So first you have to identify your variables. Your variables are very easy to figure out. We've actually done some work with this already because we've studied the scientific method. So the independent variables, go through this quickly, remind ourselves, the independent variables are not affected or manipulated by the experiment. That's a lot of words there, okay? The independent variable, remember, is something I change. We said that because independence starts with the letter I. So if independent variable is something I change, then the dependent variables, which are variables that are affected by your experimental design. Essentially, they are what you measure. So dependent variables are what you measure. Okay? So in this case, if you wanted to do population size through time and see how many families have moved into Downers Grove over time, you have time on the x-axis, which is the bottom. And then you'd have your dependent variable, which is population size. Oops. Population size. You'd have that on the y-axis. And that would be on the left-hand side. Okay? So those are your variables. We'll do some more practice with this later. When you set up your graph, you're going to have, again, your independent variable on your x-axis, dependent variable on your y-axis. You must label all of the axes, and that includes a title. If I don't see a title on your graph, I'm going to mark it, or mark it down. Okay, you'll get a point off for not placing a title there. You'll get a point off for not placing the labels there. So again, make sure labels and titles are there, just as important as the actual numbers in the graph. All right, and then finally, we're going to work on doing this on Wednesday, but you have to make sure your scale is appropriate. What I mean by that is, if we're going to go to this example here, you have to kind of make sure that the spaces in between each branch of your graph here, or each spacing in your graph, you have to make sure those are even spacing. So you notice down here every space is 1 year. Up here going up, it looks like every space is about 17 points. You've got to make sure that they're roughly the same, because when you go to compare, if the categories or the measuring points were at different widths, then it'd be really hard to see what was actually going on in that graph. And sometimes graphs can be very misleading because the maker of the graph will mess with the x or y-axis to make it look like there's not much of an effect when there really is. So you've got to be careful with that. You've got to make sure that your scale is as even as possible. Okay? So we'll practice that on Thursday. Finally, if we want to finish our graph, you need a descriptive title, which I explained a few seconds ago. Descriptive title is better. If you just put down there, graph, okay, or points or population, it's not explaining to the reader what is in your graph. So you have to have a descriptive title, and your graph also needs a legend based on how many colors or lines or shapes you used in your graph. So you have to tell the reader what is in your graph. Let's go over an example now. Okay, this will be the last thing we touch on here. Here's my example. I've got title up here, scores by team per season. So we've got seasons down here. Let's say these are, 3 basketball teams. And in 2002, we've got points. In 2003, we've got points to compare. In 2004 and in 2005. So those are our seasons. We've got our measurable points, which is our dependent variable. This would be our independent variable on the left-hand side. So we've got our dependent points on the left-hand side. And now we're recording how many points each team scored every year. So it looks like that Team B has gotten worse over time, whereas Team A got a little better and peaked in 2004, but then decreased again in 2005. By the way, right here, this is our legend. Okay? Because we're comparing three teams together, we need to have them as different colors. Now, there's one last thing I'll ask you about this. Is this graph appropriately a bar graph? So let me write that on here. Is this supposed to be a bar graph? Think about it for a second. Think to yourself. Okay. Hopefully you got a chance to think about that. The answer is actually no. Okay. Why is it? Well, we're dealing with time here at the bottom. So because we're dealing with time, this should have been a line graph. Okay. So we'll do some more practice with this in class tomorrow, and then we'll wrap up the unit here. Okay. So thank you for watching. If you have any questions, make sure they're written down. Save them for me in class, and we will get to them when I see you next time. Thanks for listening.